Okay, I'm gonna break this video into two parts. Um, I'll go through the basics here and then I'll do the sample problems in the second part. Okay, area of a circle. The formula for the area of a circle, come on, can be derived by splitting the circle into smaller segments. Remember, area is the space inside. Like we wanted to paint this circle or color this circle on the inside. We want to know what that area is. Okay, so if we break this circle apart, let's say that the green is our distance around the circle, which we call circumference. Fancy name for a perimeter. And that's represented here after we break the circle apart and line it up. It's also here. That's 1, 2, 3, 4. So I've got half my circle represented, the outside distance around, at the bottom. And then I have the other half of the distance around the circle, maybe going across the top. That's 1, 2, 3, 4. 1, 2, 3, 4. They both make a basically straight line. And that's our circumference. And each one is half the circumference of the circle. Then those little dashed lines are our radius. And we have 1, 2, 3, 4, 5, 6, 7, 8. And they're here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we go around, and these are the sides of this figure. They're straight. And if we look at the green part, I'm going to label this as R for the radius. This is like a rectangle shifted to the side, which we call a parallelogram. So the radius is the sides or the height, and then the tops and the bottoms are going to be the bases, what we call the base of our parallelogram. Okay. And so as I start to fill in the area, to find the area of a rectangle is base times the height. So I have the base. And the base is 1/2 of the circumference of the circle. That's what we said. It's the distance that is half the circle. And then our height would be the radius. So we would do base, right? This is kind of what we would call our base, times the height of that parallelogram. That's a little weird. I know from our last lesson that the circumference of a circle can also be written as 2 pi r or pi d, pi times d, but I want radius, okay, because we're working with a radius already. So I'm going to take that c out, and I'm going to put this sucker in its place. So I still have the 1/2, but now it's going to be 2 times pi times r, and then still times another r, another radius. I can simplify that formula a little bit further. Now I can put some numbers in, and I can pick things out of my circle to work for the r. But 1/2 and 2, that's 2 divided by 1/2. This cancels out and becomes 1. So now it's 1 times pi times r times r. So I don't have to write this 1 anymore. I can just write pi times r, or we can simplify that a little bit further and go pi r squared. So that's what the formula for the area of a circle actually is when we break it apart and put it into sort of a quadrilateral. So what general 2D figure do you see when the pieces are rearranged? We see a parallelogram. And then based on that, how is the circumference of the circle related to the length of the parallelogram? Well, the length of the base of the parallelogram, that's the green part, is equal to half the distance around the circle, or half the circumference of the circle. Okay, that's kind of where all that comes from. The area, okay, area of a circle measures the covering of a two-dimensional object. Use the formula A for area equals pi. Remember, this is area. Pi is 3.14, and then r is the radius squared, where r squared is equal to r times r, radius times radius. Not doubled, not times 2, but the number times itself. So in number 3, right here, we are given, since it goes from the middle of the circle to the edge, that's halfway across the circle, that's what we call the radius. So this is 3 inches for the radius. Formula for the area of a circle is A equals pi r squared. We're going to plug in the values. I'm going to take pi out, put 3.14 in its place. And then I'm going to take that r out, and I'm going to put 3 in its place. Okay, so that's shown here. So then we do the math. 3.14 times 3 times 3 gives us 28.26 inches squared. Area is always in square units. We're talking about a length and a width, 2 dimensions. Number 4, since the line goes all the way across the circle from edge to edge and through the center, this is a diameter. But I need radius to use for the area of a circle. Radius is just half the diameter. Half the diameter. So half of 10 is 5. So my radius is 5. Still using the formula pi r squared. Plug in the values. I take the pi symbol out and put 3.14 in its place. I take the r out and I put the 5 in its place. So this is really like 3.14 times 5 times 5. And when I do that math, you can use your calculators. We're going to get around, around 78.5 centimeters squared. In number 5, we are given a radius. It goes from the center to the edge. It's halfway across. This is the r. I don't have to do anything to this. Only when I get a line that goes all the way across, I need to take half of it to work for area. Okay, the formula is A equals pi r squared. Plug in our values. Take the pi out, put 3.14 in its place. Take the r out, put the 6 in its place. So we're going to get that. And we can expand that a little bit more. 3.14 times 6 times 6. Put that in your calculator, and we should get about 113.04 meters squared. Okay, so in 6, 7, and 8, and 9, these are example problems. We're going to be not only finding the area, but we may be finding the radius, okay? So we can still use the area of the circle, and we may have to find the other parts of the formula by solving an equation. So this is where this is where the video is going to end, and you try and solve 6, 7, 8, and 9 on your own, and then come back to the video part 2 and see if you get them right. If you decide not to work them out, I still think you need to watch video part 2 so that you can see how I'm solving for the one variable. It may be the A, it may be the R, okay? See you in a minute.